First off, you're going to want to go to your network script, network.gd. And in this network script, we're going to make a new function. This function is called reset network connection. And what this is going to do is it's going to check if we are the current network peer, and it's going to set network peer to null. So the reason why we're going to be doing this is that way when you get disconnected from the server, it will actually reset the entire connection. And so this network peer, basically, it's telling the entire scene tree. There's no longer a multiplayer enet that's being used for the entire scene tree. We are just going to be setting that to null. In the server disconnect, you want to go through all of the children in the persistent nodes right here, and you want to check if it's in the network group. Now we'll set this up later. We haven't actually added those groups or anything, and it's going to destroy that child. So the reason why we're doing this is because we need to make sure that all the networked objects get destroyed and reset upon the server disconnected, because you don't want to leave all of the players that were existing before when you disconnect from a server, and that will also cause issues. So it's better to just destroy them. And then below this, we're going to be using our reset network connection, this thing that will basically tell, hey, set the network peer back to null. We're no longer using our current network connection that we were before. Now we'll reset everything. Add a new scene. We're going to just do a user interface node. We're going to call this simple prompt. I'm just going to have this set to full rectangle under the layouts. We're going to be adding a panel, and I'm just going to use, for this panel, I'm going to set the layout to center. And I'm just going to use my own values. You can resize this and do whatever you want with it, but I'm going to do 256 on the X and 210 on the Y position and 1,408 on the size and 660 on the size on the Y. Then I'm going to add a button node under this panel, and I'm just going to rename this button to OK. The layout for this button is going to be at the center bottom. Under the rectangle parameters, on the X position, I want to set this to 447. On the Y position to 350. On the size, I want to set it to 514 and 197 for the heights. Now for this button, we're going to add a custom font. We're going to be using our base font resource for this, and then you want to do make unique. What make unique does, it allows me to edit the values without changing the base, the actual TRS file, so it'll actually make its own resource. I'm going to set the size to 100. Now I'm going to set the text to OK, and that's our OK button. Now I'm going to set up a label. The layout on this label is just going to be in center. The position on the X value is going to be 444, and the position on the Y is going to be 384.5. The size on the X is 1032. Size on the Y is 87. I'm going to add in my fonts again. I'm going to make it unique so I don't alter this resource that we have here, and I'm going to set the size to 100. The text by default is just going to say simple prompt. We're going to set the alignment to center and the vertical alignment to center. And there you go. We have our simple prompt pop-up. Now we're going to save this. You could save the scene. We're going to add a new script. We're going to hit create. We're going to connect our OK button signal when it's pressed back to our prompt. We're also going to set up another function, set text, and this text will take this argument right here, and it will set the labels text to this text argument that we put here. Now, when OK is pressed, we just want to say get tree.change scene to the network setup. By default, I'm just going to have it go to the network setup because that's most of the time. Every pop-up's just going to take you back to that setup scene because it's talking about what went wrong in the networked connection. So that's why we're going to have it go back to network setup. You could save this, and we're going to go back to our network setup scene and go back to 2D. And this canvas layer right here, we're actually going to change. We're going to call this UI. Just rename it to UI. Now, the reason why we're going to be doing this is we're going to need to be able to instance our prompts under some sort of UI canvas layer. So in this UI, we're going to make a new script. I'm just going to call it UI.gd. And in the ready function, we'll set global.ui to self. And when we exit the tree, we'll set it back to null. So when we leave the scene tree, it just resets the reference that global has of this UI. You can save that. We can go back to global, and we'll set a reference of var UI equals null. Now, there's going to be a couple of things we're going to have to change in our network setup. So go back to your network setup script. And since we renamed this to UI, this canvas layer right here, we renamed that to UI. That didn't change here where we're actually getting references to them. So we're going to have to change this and just say UI device IP address UI start game. And that should update it so it actually has the correct node references. So you can save that. Now we're going to go back to our network script. And in our network script, we're going to check if global.ui is not equal to null. And this is all going to be under the server disconnected function. We're going to check if global.ui is not equal to null. Then we're going to set up a prompt that's going to be the global instance node of the simple prompt under the parent global UI. And then it's going to set the text of this prompt to disconnected from server. So now you can save this, and we can actually test this right now. I'm going to hit the run scene. You can see I have two players. I have my server and I have my client. I exit, and here it says disconnected from server. I press OK. It takes me back to here. So you can see our players are still in, and this is because they're not under the networks group right now. We're getting a lot of errors, and so we're gonna fix that. We're gonna go into our player scene, and in this player scene, we're gonna add a group. We're going to call it net, short for network. We're going to save that, and we're going to do the same for the player's username text. We also want that to be destroyed when the player gets destroyed. And we're going to go into our player's bullets, and we're going to add that networked group here. So now that's three things we added this network group to: our username text, our bullet, and our player. And that's everything we want to get destroyed when you get disconnected. This time I'm going to run this end as the server and this end as the client. That way I can see my output. I hit join server, and this server decides to close connection, disconnected from server. But you could look and you could see that we're actually getting a couple errors. No network peer assigned, unable to get networked unique ID. And this is all tracing back to when we're checking if is network master in our player. So we need to make sure that we have a network peer assigned before we try to get a unique network ID. Instead of calling network master right here, we have to do, if we have a network peer in the tree, then we can finally check if we are a network master. We're going to have to do this over every single time we check if we are a network master. So let's scroll all the way up to the top of our code. And you can, if you want, you could just search for it. You could just do Control F is network master. And let's go to the very top. So the first reference where we check we are network master is after this idle frame where we yield and we set the player master to self. Before we check we are the network master, we want to say, hey, does the scene tree have a network peer? If it doesn't, then we can't do this because the network's just not there, and the connection will be closed if it isn't. In every reference, like right here, if is network master and visible, do if get tree.has network peer, grab all of this code all the way down to move and slide, tab that over. Now when we're checking if the tree is a network server, we also want to check if it has a network peer. We're going to go down to this set HP. We're going to say, hey, do we have a network peer? We're going to tab this over. Same for the puppet HP. Basically any reference when we're checking if we're the network master. Same with the username sets. Same with the puppet username sets. The network tick rate we already changed. And on destroy, we also want to check if the tree has a network peer. And on exit tree, we also want to check if it has a network peer before we check if we are the network master. That's everything in the player. So we can save that. The only other definitions of checking for is network master is in the bullets. So let's go here. And in the bullet, we check if is network master in the ready function right here. So we also want to say, hey, does the tree have a network peer? If it does, then yes, we can go through and check if we are the network master. We also do this in the process function. So check that, tab everything over. On the destroy timer, when we're checking if the tree is a network server, we also want to check that here. If we have a network peer, tab that over. And that's everything. We can run this again, and we're going to see if we get any errors when I close the server on us. I join the server, I'm in. Now I close the server, and it just says disconnected from server, and we get 0 errors. That was just a fix for all of the errors that we were getting before. So go back to our network script, and we're actually going to connect one more signal. That's the connection failed signal. So if this connection failed signal goes off, we also want to give a prompt to the player saying, hey, the server, there was a connection that failed between the server and the client. We want you to restart the connection process. So do function underscore connection failed. And we're going to essentially do the same thing where we destroy all the nodes that are under the network group and reset our connection. And then we also want to copy over our prompt code where we instance a new prompt right here. Instead of saying disconnected from server, we're just going to call it and say connection failed. And there you go. You have the connection failed and you have the server disconnected pop-ups. We want to go to our game scene right here, game.tscn. Go back to your game scene and you want to set up a canvas layer. And we're going to call this canvas layer UI. Remember, we need a UI for this too. So that way we can actually instance under that when we are instancing those pop-ups. So drag this UI.gd script onto the UI node, and that's everything we need. So we can save that. We can run. I'm going to start up the server and I'm going to disconnect the server. server. So it says disconnected server. They say okay, and they are taken back to the screen. Go to your game scene. Now in your game scene, we're actually gonna make a new canvas layer. I'm just gonna call it game UI. Then we're gonna add a control node under this. And I'm gonna set the control layout to full rectangle. Then I'm gonna add a label under this control node. This label is gonna be called winner. Now set the layout of this node to H center wide. 504.5 on the height, 93 on the size. The alignment, I want center and vertical alignment to center. I'm just gonna set the text to winner, winner, chicken dinner, if you guys can figure out what that's from. For our custom font, I'm just gonna drag in our base fonts, but then I'm gonna make it unique by clicking this arrow next to it and hit make unique. That way I can edit the settings without changing all the other fonts in the game. And I'm going to set the size of this to 120. I'm going to set the outline size to 7. And I'm actually going to give it a black outline. I'm also going to go down here to custom constraints. And I'm going to set the shadow offset on the X to 6. And the shadow offset on the Y to 6. And then under custom colors, I'm going to font color shadow. I'm going to check that. And then just have it set to black. Now we're going to add a timer under this winner label. And this timer, we're going to rename this to win timer. The wait time for this, I'm going to set to 2. Now we're going to add a script to our winner label. I'm gonna set up a function. It's gonna be a sync function. Get tree.change scene to network setup.tscn. The reason why we're using sync is when we send out the signal, we want it to be called on our end and all the clients' ends. If you don't do sync and you just say remote function, it will only be called on the other machine's ends. It won't be called on the current machine that's executing this. Now we're going to connect our win timer signal, timeout. We're going to connect that all the way to our winner label. Press connect. Now we're just going to check if the current scene is a network server, and then we're going to send out this return to lobby call. So we only want to send out this RPC when we are the server, just because if we have the client send out this RPC, well, let's say this win timer is going to go off on every single client. So every single client is going to be telling every single client to return back to the lobby, and that's going to cause issues if we're all telling each other at the same time. So it's good to just have the server tell everybody. The server's the master of the game. We need to actually store the amount of alive characters in the game, because we never destroy any of the players in the game. They never get destroyed when they die. They just get hidden. And so one of the issues with this kind of system that I'm doing here is you can't tell which players are alive because some of them are just hidden. They're not visible. So simply just going down a scene tree and saying, hey, how much players are actually here doesn't work anymore. So to compensate for that, we have to go into our global script. We're just going to make a new variable, and we're going to call it alive players. I'm just going to set that to an array, an empty array. Now we can save that. Now that we have this array set up in our global script, we need to go back to our player script and go to the very top of your player script, all the way to this ready function. Now above this yield function, I'm just going to write global.alivePlayers append self. So we're going to add ourselves to this global.alivePlayers array. We're going to scroll all the way down, all the way to our sync destroy function. Now when we destroy the player, obviously our player is not going to be alive anymore. So all we have to do is erase our player from the array. So global.alivePlayers.erase self. That will remove us from the entire array. And if we ever leave the scene tree or get destroyed, we also want to say global.alivePlayers erase self, which removes us, and we are no longer an alive player in this array. We could save this, and this is basically most of the stuff in our player script. We'll actually come back to this later on. But now we are going to make a new script for game UI. So add a new script, just leave it as that. At the very top, we're going to declare two variables. OnReady var win timer is just going to get the path all the way to this winner timer, and already var winner, which is going to get the path to our winner label. On the ready function, we're just going to hide this label. Whenever you start the game, usually no one's going to win right at the start of the game, so we want to make sure winner is hidden so you don't see that. Then in our process function, we're going to check if global.aliveplayers.size is less than or equal to 1. We're also going to check if global.aliveplayers0 index 0.name is equal to the string of getTree.getNetwork unique ID. So why do we need to check if our name is equal to the unique ID? The thing is, we only want to show the win screen on the person that actually won. And so if there's only one player left, then index 0 is always going to be that last player left. Index 0, because the array starts at 0, and that's going to be the player that is alive. So we're checking if that player's name is equal to our unique ID of our tree, because if it is, that means that's the current player on this machine that we are controlling. So that means that this machine is going to be the only screen that's going to show this win screen, because no other machine needs to see this. Under this if statement, we'll say winner.show, and then we're also going to say if when timer.time left is less than or equal to 0 when timer.start. What this essentially is saying is, hey, if the when timer has not been started, so if the time left is less than 0, meaning it hasn't been started, then we can start the timer. Because the issue is I can't just say when timer.start right here, because this is in the process function. So it's going to continually say when timer start, when timer start, when timer start, when timer start, and it will never end if we do that. So we have to use this to check if we actually have started a timer before. Also, one more thing that we want to check in this process function, as you can recall, we're saying, hey, get tree.getUnique network ID. And from the last tutorial where when you get disconnected, it will still be trying to get the unique ID, even though the tree doesn't have a network peer anymore because it's been destroyed, and it's still trying to recall, and then you get errors. Anyways, what we want to do before we actually can call get tree.getUnique ID we want to say and get tree.has network peer. So we want to make sure the tree actually has a networked enet or whatever network service you're using attached to the scene tree. So now you can save this, and now we can test the game. So now I hit start game. I'm gonna move around, start killing some people. As you can see, I killed everyone, I get the win screen, and it takes me back to here. Now, there's one major problem. It didn't remember we were in the lobby. Since it doesn't remember that we already set up this configuration, we still get this UI. We don't want to have to rejoin the match, because you can see I'm still shooting. I'm still alive. See, I'm in the match. We're going. So we need to check, hey, if there's already a network server attached, we need to hide all this configuration, and we need to re-enable all the people that are died. Everyone that's dead cannot shoot, and they cannot see themselves. So we need to make sure we re-enable every single player in the scene, and we need to hide this configuration UI whenever it's restarted, when we still have a server already created. So let's go over that. Before we go into the network setup and start actually fixing some of this, go back to your player script and scroll all the way down to your destroy function. We're gonna make a new function. It's a lot like the destroy function above this destroy function. We're gonna call it sync function enable, and we're gonna set HP back to 100. We're gonna set can shoot to equal to false by default, because usually when the player's re-enabled, he's re-enabled in the lobby and we cannot shoot in the lobby. We're going to update our current shoot mode to false. We're going to show our username text instance so we can actually see our username. We're going to set visible to true so we can actually see ourselves. We're going to undisable our collision shape, and we're going to undisable our area collision shape. Then we're going to check again if the tree has a network peer, and if we are network master, and set global.playerMaster equal to self, because we are now alive again. And then we're going to check if global.apply players does not have our self in this array, then we're going to add our self to that array. And that's everything for our enable function for our player. So you could save that now. And now we're going to go to our network setup script. And remember, a while ago when we first set this up, I just put pass here because we're going to need to put all this stuff in here later. Well, this is the time where we're actually going to put everything in here that we need. So instead of pass, now we're going to write multiplayer configuration UI.hide. Basically, if you look in our scene tree, all of this is our multiplayer configuration UI. Hide all of that. That's all hidden. And before we go on to anything else, we need to actually set up the spawn locations for this lobby system right here. So this is going to be a lot like the spawn locations right here. It's actually very similar, just more condensed in their positions. Exact same node setup. We're going to go back to network setup, click on network setup, add a new child node. We're going to add a node, just a normal node. It's like a container. It's like a folder. That's all we need. Spawn locations is what we're going to call it. We're going to right click, add node, right click, add child node. We're going to add a position 2D to it. We're going to call this 1. In the transform position, we're going to set that to 192 by 192. Now we're going to duplicate this, and the position of 2 we're going to set to 1728 by 192. Now we're going to duplicate that. We're going to get 3. We're going to set the position on the X to 960. We're going to duplicate that. We're going to get 4. And on the transform on the X, we're going to set to 192. And the transform on the Y, we're going to set to 896. We're going to duplicate that. We're going to get number 5. And the position on the X, I'm going to set to 960. Leave the position on the Y to 896. Now we're going to duplicate that. We're going to get 6. And the position on the X is 1728. Now we have all of our spawn locations in. So this is literally the exact same code as it is in the game. So you could just go to your game scene right here and just copy all of this for loop right here. Just copy all of that and go into here, and you can paste that in. Just make sure everything's tabbed correctly over, so it's all under the for loop. But now you're gonna see, hey, we're getting errors, current spawn location, instance number is not declared. Well, we just never declared those variables. So at the very top, above these onReady variables, we can declare these two variables, current spawn location, instance number. We're gonna set that to 1, and current player for spawn location and location number. We're gonna set that to null. Well, this won't spawn our players in those positions. It will only reset our players' positions back to the correct positions. So when we go back into network setup after we beat a game, that's when this is gonna be triggered. But when we actually start initially spawning in the game, that's not gonna be used, because we can look down here and we're just still using these random values. To fix this, instead of making these random range values and getting a vector2 out of it, we're gonna say get node spawn locations, and we're just gonna put a slash, because you see how all of these nodes under is saying spawn location /1 2 3 4 5 6 for each spawn location. We're gonna use this, and we're actually gonna parse our own string. So we're gonna do plus string current spawn location instance number. Oh, but there's one issue right here. You see how we're doing plus string right here, but this is a closed parenthesis right here. So this means that it's not going to be added to this string. It's trying to add it to this get node function, but that doesn't work because that's not a string. So to fix this, just remove this parenthesis. Now we don't have enough parentheses, so just add it to the end here. That should fix it. So now we're getting the correct node. We're getting the correct spawn location node. 2 parentheses. Don't go past this last one. Just 2 parentheses in. Say dot global position. So that gets the position of this node. All of this right here is just getting the correct spawn location node, and then this is just getting the position right here. So this is just getting the position, this is getting the node, and we're using this current spawn location instance number and putting that into a string. All we need to do to get all of this working that we set up right here, at the very bottom, just say current spawn location instance number plus equals 1. And so for every instance player, it will add 1 to that spawn location, and it will go down the list of players in the exact same order and spawn them in the right spawn location. So now you could save this, and now we can test the game. All right, I have 3 players connected. We started the game. I kill the 3rd player, and I kill the 2nd player. I get my win screen, and we get reset back to our main screen. Now you can see there's one more problem. Where's all the other players? Well, remember how we set up that enable method? We sort of didn't use that yet. There's one more line of code we need to add. I completely forgot about it. So close all of this. We're gonna scroll all the way back up in our network setup script. And under this update position RPC, we want to do player.rpc enable. So this will send out a remote procedure call of enable on our player, which basically updates all of these values, makes the player visible, sets player master, does all that fancy junk that will make our player alive again. So now I just test this again. You can see when our players are connecting, they're actually connecting and going to the right spawn locations. Now I can hit start game. All right, I killed the 2nd player, we got the win screen, and we are back in the game. We all spawned in, we all got set up in our correct positions, and I still have my start game button, everything's connected. So now I can close players, they disconnect, no issues, and now I can't start the game because I only have 1 player.